Today's lesson we're looking at durability, product safety, tolerance and sustainable design. In the first section you're going to take notes that will help guide you to answering the exam style questions at the end, and then at the end we've got some questions that are on the above headings. So today's aims: understand how product safety impacts outcomes, to be able to understand tolerance in materials and components, to be able to understand how durability, sustainability and maintenance impacts product outcomes, to be able to apply understanding to past paper questions. So what I would like you to do is split your page up into 4 sections. So we've got tolerance, sustainable design, product safety, durability and maintenance. So if you pause it now and then click play when you've done that. First one we're going to look at is tolerances. So this is where an allowance is made for the products, parts, materials to not meet their exact sizings. So it basically gives you an allowance on the exact sizings. So for example, if the product's diameter is 5mm, the tolerance might be 4.9 to 5.1. That would give you a 1mm tolerance. So engineering drawings often display tolerances. If we look, we can see on these numbers, if we look at C, it can either be made to 380 or 0.375. So it's displaying there the tolerances allowed within that part manufactured. Okay. We've got some symbols that you might need to know. So we've got this one here, which is a circle with a line through it. That means diameter. The plus and minus is normally what tolerance is. So if you see that anywhere, that's normally that. Sometimes it's in drawings, but not always. It could just be a number next to the symbol. Solving some tolerances then. So 10mm, we've got a plus and a minus tolerance of 0.2. That makes it 9.8 to 10.2. What do you think the next one will be? So the next one, with 0.5mm, 99.5 to 100.5. Then we've got 0.1mm on 2mm, so it's got to be 1.9 to 2.1mm. Label the drawing in figure 4 where the specific tolerance is shown. So just see if you can find it, and it is just there. So it's showing you that it can either be made to 20.2 or 19.8 on the tolerance, and that will be for the diameter of that part. Product safety. So how can we make sure a product is safe for customer use? And it's important we do that so that we are not liable. So if we are making a product and it harms somebody, basically you are protected from that. So we can pass it through testing and standards. We can make sure that non-toxic finishes and materials are applied. We can make sure it's suitable for the market, so it's age appropriate. We can also error-proof our design, so we can make sure it works in the correct way. Take a plug, for example, that can only be put into the wall in one particular way. So these are things that we can do. On a lot of products now, there's age limits. So for example, children's toys are often very heavy on what age restrictions they should have to make sure they don't choke on them or there's no sharp edges, etc. Also, if you had a toxic material on them, if you've got little children, maybe between 0 and 3, that's obviously going to harm them. Suitable warnings and instructions on how to use the product, etc. What would happen if the products aren't safe? So, if you were a company and someone hurt themselves on your product, that gives your product a poor reputation, so you'd lose customers. You have to have a recall of that product. Cars do this quite a lot. So for example, one of the latest BMWs that had a problem with one of the fuel parts, and what was happening was when it got too hot it was catching fire, so they had to recall around about 1 million vehicles and have this part changed to protect their customers. One of the people was actually burned in one of these accidents, and he was able to put on a lawsuit, and for that product he was able to sue them and get lots of money for it. Lose the ability to sell products within a country. So if it's a big disaster, you might lose your rights to do that. So that's safety. Sustainability. Sustainable resources are ones that can be maintained over time. So if you have trees, for example, we can replant them and we can regrow them after being cutting down. It's what's known as a renewable resource as well. Things like metals, we can't make more of them once we've done. Plastics is made from oil. Once we've used all the oil up, that is it. We can't make any more. Sustainable resources are meant to have as little impact on the environment as possible. So how can designers ensure their designs are sustainable? So they can choose sustainable materials, they can give appropriate disposal or recycling instructions, or they can manufacture products in a less impactful way. So is there a way to make it so you're using less energy to make this product? Could you have a product that is easily recyclable or made from the same materials to make it easy to recycle? Could you choose, for example, materials such as timbers that can be regrown or biodegradable products? Durability and maintenance. So how durable something is how long the product and material can last. Generally, the more durable something is, the better. If our product lasts longer, we're obviously not going to have to buy new products. It's going to save us money in the long run. So customers and manufacturers are more likely to buy a durable product than one that isn't going to last. However, there is something called planned obsolescence. This is where products are supposed to die after a few certain periods of times. This can be for loads of different reasons, including profit, not being able to make the products last an extended period, etc. A great example for that, which most of you have, is smartphones. So for example, if you had an iPhone 4 at the minute, you couldn't update to the latest iOS software. Also, they're made from glass. I think it's about 150 quid to get your screen replaced, and most people take them to Apple to get them done, but they've designed them essentially to be able to be broken because they make more money from it. So we've got some examples of planned obsolescence. We've got disposable plates, disposable cameras, batteries after a certain amount of time we can't use them again, light bulbs are the same, and also ink cartridges for printers. We can maintain products in a variety of different ways, so we can repair them, replace parts through disassembly, not overusing a product, using it correctly, storing and caring for the product correctly. So let's have a look at some examples. So things that we can maintain, we've got shirts, you can easily tie buttons on, we can hang them up, it tells you on the tag how you can wash them. Things like cars are designed a lot for disassembly, so every part of a car can be taken off and it can be replaced. You should also every year get your car serviced to make sure it's running right. We do things like MOTs to make sure they're safe and legal to drive. When you do get a car, it is important that you also check your oils and stuff to make sure that vehicle is running correctly, and overall it will save you money in the long run. So we're going to have a go at some exam questions. You should be used to this by now. So it's get busy. So when you're looking at the exam question, box your command words, underline keywords and the marks, structure your response, you are ready. So we're going to have a go at the first few together. I'm going to give you some examples on how to structure it. So we've got give one example of each of the following materials and explain how they benefit the design and use of the product. So we're just looking at the sustainable ones. So I've looked at some ideas I come up with. It was forest materials, responsible design, and good marketing for companies. That was the first one. The second one is tolerances. Explain the meaning of the tolerance in figure 5. Explain the tolerance and add and subtract 0.3 from the first value. That's 2 marks. So if you want to pause the video, have a go, and then we'll go through the mark scheme. Okay, for the sustainable materials, things you could have had, this is worth 3 marks. So, more sustainable materials may be chosen instead of the cheapest. You gave an example of a sustainable material, so I said forest materials. Consumers may pay more for sustainably designed products. Different material choices by producers. Resource depletion may make it necessary to find other sustainable materials. And also it's a good PR for companies. If you've got anything else that might be included, 1 mark is awarded for identifying your material and 2 marks for how the product could be benefited. For the tolerance, up to 2 marks. The tolerance in the dimension is 0.3 plus or minus. This means that the 11.5 diameter dimension can be 0.3 bigger or smaller, but no more. This would mean a maximum dimension after manufacture of 11.8 and the smallest of 11.2. So if you'd have put an explanation and then the figures of the addition and subtraction, you'd have got your 2 marks. This was looking again at tolerances to explain how allowing tolerances on the critical dimension of engineered products can help to control production costs. This is 4 marks. So these are my structured responses to my question. So I thought that making items to absolute dimensions, so we've got to make it to 10 mil, absolute, that's going to be pretty difficult to do, and it's time consuming. So that's one thing why we might have tolerances. It's going to cost more to make things to absolute dimensions. So if we had a tolerance of a mil, we could either make it 11 or 12, and in between those, or 9 and 11 I should say. So that's going to make it easier for manufacturers to do it, and also less time consuming and cheaper. They can optimize cost, so it makes it more cost effective, and they can still make sure that the product functions as required. So pause the video and then have a go at the exam question, then I'm going to go through the mark scheme. Up to 4 marks then for a clear explanation. Creating components to absolute dimensions costs too much money. This is because there is inherent variation in manufacturing processes, so designers have to consider this when dimensioning critical features appropriately. With the inherent variation, there is always an acceptable compromise that could optimize a component's production costs. This is the acceptable tolerance of a component possible for the application and capability of the manufacturing process and expected cost. So basically, if you'd have put in the points before, you should have got 4 marks for that. So 4 different points for different marks. The next 2, looking at safety. State 2 ways a designer can make sure a product is safe to use, and explain why it is important for the manufacturers to make sure products are safe before they are put on sale. Use your sheet that you use to make your notes on. I'm not going to structure this one for you, have a go yourself. Then I'm going to go through the mark scheme. So if you pause the video, and then we'll come back. So, designers can test their products. Designers choose materials that are non-toxic. We should have got that one. Designers can ensure they do not use coatings that may be hazardous. Designers can use their products suitable for the target user. We did talk about that. And designers can error-proof their designs. You should have got 2 marks for that one. The next one now. So explain why it's important for manufacturers to make sure products are safe before being put on sale. It's important to ensure manufacturers ensure products are safe so that their customers do not get injured. If they suffer an injury, the manufacturer will be liable and face prosecution or trial. Must ensure they're safe to meet regulations and standards, for example, British standards. It might not be sold in that country if it's not met, affecting the reputation of the company. Manufacturers have a duty of care to retailers and customers. So you should really have got 3 marks for that. That overall sums up manufacturer, durability, safety, and tolerances, and also sustainable design.